Hi there, it's Professor Monty, and we're looking at quadratic functions and their graphs, and specifically using translations and reflections. So let me show you a bunch of keys here. You may want to take a picture of this because I think it'll help you to refer back to, but make sure when you're doing your problems you can do it without referring back to it, so when you get to the test you can do it by yourself. All right, so I'm starting off with f of x equals x squared. And remember, f of x just means y. So we just have y equals x squared, which is just your normal parabola opening up. I'm going to use the letter a to be a positive number. Okay, it's greater than 0. So if I have x squared, and then I add a to it, that moves the whole graph up a units. If I subtract a, it moves the whole graph down a units. Because think, if I have y equals some number 7, and then I add 2, well, now it's a 9, it's 2 higher. If I subtract 2, it's 2 lower. So these follow pretty much as you would expect. This one's a little weird. If I go x plus a squared, it actually moves it to the left. I like to think because it gets there, say, 2 units earlier. So whatever a is, if I do x plus a inside the parentheses before I square it, it moves it left. If I do a minus a, it gets there later, so I go to the right. That many units, a units. If I have a in front of the x squared, remember, we're saying a is a positive number. If a is between 0 and 1, it's a fraction, then it shrinks it. Instead of going up like this, it goes up slower. If it's a half, it only goes up half as quickly. If it's bigger than 1, it's a stretch. So it goes up, if it was normally like this, and now it's 2, it goes up twice as fast. So it goes up faster. And then if I put a negative in front, any y value that before was, say, a 4, now it's a negative 4. It actually flips it across the x-axis, which is a flip in the y direction. So it's a reflection in the x-axis, what it's called formally, but it flips it in the y direction. And then I like to say work from closest to the x and work your way out. So let me show you a couple examples. So I'm going to build up to this. Plotting points may not be a nice way to work around this, but I can get up to this pretty quickly. So again, remember that just means y. Sometimes I'll write it as f of x, sometimes I'll write it as y. But to start off, we're just saying y equals x squared. Okay, we know that's just a nice little parabola. Now let's work from the x. The first thing I do is subtract 3. So what is that x minus 3 squared going to look at? Oh, remember, that moves it to the right. So now instead of that, I go over here to 3. It's the same graph, it just moved over 3. Okay, let's keep working from there. I'm subtracting before I do the plus 4. So now I have, and I'm saying y, you can say f of x if that makes you happy, negative x minus 3 squared. So now I'm using this graph, but I'm doing the negative. Remember, the negative flipped it. So now this is reflect or flip, and again, in the y direction, across the x-axis. So now what it's going to look like, it's still over here at 3, but now it's upside down. And now I'm going to add the 4. That's my last step. Y equals negative x minus 3 squared plus 4. That 4, remember, goes up. If it's inside touching the x, it moves in the x direction. But if it's outside, it just moves the y. So I'm going to go up 4 from here. So now my graph, and I'll just put it here. I was over 3 and up 4. I'm here. The graph looks something like this. This is the point 3, 4. And what I like to do is plug in that 3, make sure I get 4. If I plug in 3 here, oh, I get 0 squared negative 0 plus 4 is 4. So when I plug in 3, I do get 4. I know that point's on the parabola, and I've graphed it quickly. And some people just in their head, they go, oh, write 3, flip it over, go up 4. Boom, they go straight to the answer. So here's the steps where you can go straight to the answer, and that's my graph. Let's try another one. So this time, there's only a couple things going on. Again, I'm starting off, and we'll write f of x. Maybe you want to write that. If it's just x squared, I know that's just my normal parabola. Vertex at the origin, opening up. I'm going to add the 5. That's the closest thing. So, well, f of x, x plus 5 squared. Remember, it's inside. It's touching the x, so it's going in the x direction. Remember, if I put a negative 5 in here, it makes that 0, which is where my y value is at 0. So this goes left 5. So this graph's actually going to look like this. going to be over here at -5. And notice if I put in -5 there, I do get 0 as my y value, so that point works. And then this 2 on the outside, it's not being added or subtracted, so it's not up or down. It's bigger than 1, it's a stretch. It just means it's going to go up twice as fast. So f of x equals 2 times x plus 5 squared. This is a stretch. And that's my last thing, so I'll put it down here. I'm over here at -5, 0. But I'm going up faster. So just make it look like it's going up faster. We said stretch, maybe that's enough. Maybe your teacher wants you to plug in a point. So maybe plug in -4 to see where it goes, y value. Maybe plug in a 0 to see where it goes. Notice if I plug in 0, it's a big number. It's going to be 25 times 2. It's going to be 50. At 0, I'm all the way up at 50. It's getting really thin and going up quickly. But that's the idea. So hopefully that helps. Again, I would recommend taking a picture of this, learning those, thinking about why they are the way they are, and I think that'll help you out. But once you get the hang of it, you can graph these super quickly. And quite honestly, it's kind of a little bit of fun. So hopefully you'll find it fun too. But stick with it, learn these things, and you'll get them done pretty quickly as well.